The leopards, Panthera pardus, are among the most widespread felids, with a broad geographical range across sub-Saharan Africa and parts of Asia. Their success as predators depends heavily on behavioral flexibility, opportunistic feeding, and morphological specialization. Among the traits enabling their predatory efficiency, speed, and burst locomotion play critical roles. Understanding how leopards harness speed, agility, and stealth in hunting can elucidate predator-prey dynamics and inform conservation strategies. A landmark study in the Okavango Delta used high-resolution GPS/IMU collars on 4 male leopards. Researchers recorded the first high-speed movement data for these individuals, finding that most runs were short, less than 100 meters, with a maximum measured speed of 5.3 meters per second, approximately 19.1 kilometers per hour in that study. The study also reported average daily travel distances of approximately 11 kilometers and maximum single-day distances of approximately 29 kilometers. The authors noted that these speeds are relatively slow compared to other large predators, which suggests that high-speed chases are rare and constrained by terrain, prey, stealth requirements. The recorded 5.3 meters per second is likely a conservative estimate, constrained by collar sampling rates, smoothing in data processing, and environmental factors, e.g., vegetation, terrain. Leopards typically do not sprint over long distances. Instead, their hunts combine stealth, sudden bursts, and short pursuit distances. In popular, non-scientific reports, leopards are often said to reach up to approximately 36 miles per hour, approximately 58 kilometers per hour. But scientific data from wild individuals using high-resolution tracking tend to give much lower observed maxima. Some of the discrepancy arises because captive or unobstructed running on flat terrain may allow higher speeds, but these are rarely sustainable or ecologically realistic in wild hunts. Thus, the biological peak sprint speed of leopards remains uncertain. Empirical evidence suggests approximately 5 to 6 meters per second in wild conditions, but physiological capacity might exceed that under optimal conditions. Leopards predominantly rely on ambush predation rather than long pursuit. They approach prey quietly, often using cover, terrain, and wind direction to minimize detection. Movement is slow and deliberate, interspersed with pauses to reassess surroundings and prey behavior. In behavioral classification from movement speed data, leopards show distinct states: rest/stationary speed approximately 0, feeding or handling, meandering -- interrupted locomotion, moderate speed, frequent stopping, turning, directed movement, relatively higher speed, straighter paths. They typically move most of the time in meandering and directed modes, reserving full burst only when closing in. Once the leopard is within striking distance, often within 5 to 10 meters, it launches a powerful short-duration sprint. The final burst may span 20 to 50 meters depending on habitat. During this phase, acceleration is critical, not maintaining top speed over long distance. The leopard must manage turning and directional changes, as prey often reacts unpredictably. Rather than out-sprinting prey over long distances, the leopard depends on closing the distance stealthily, so the sprint is short and decisive. Because the sprint is short, often under 10 seconds, heat accumulation, anaerobic demands, and risk of injury constrain longer chases. Leopards are generalist predators, with diet breadth varying by region. Their prey includes medium ungulates, e.g. antelope, deer, gazelles, wild pigs, hares, small mammals, and birds, occasionally young herbivores, or livestock in human-dominated landscapes. By predating on herbivores, leopards help regulate prey populations and influence vegetation dynamics. Their presence modulates competition among carnivores and helps maintain trophic balance. The clouded leopard is a medium-sized cat with adults typically weighing between 16 and 25 kilograms and measuring about 85 to 100 centimeters in body length, not including the tail. Despite its moderate size, the species exhibits a highly specialized anatomy designed for both speed and vertical agility. Its legs are short yet powerfully muscled, and its paws are proportionally larger than those of any other big cat relative to body size. These adaptations allow it to grip uneven forest terrain and tree bark with precision. The name clouded leopard derives from its striking coat pattern, large, cloud-like blotches of dark brown or black on a tawny background, which provides exceptional camouflage in dappled forest light. This coloration not only conceals the cat from prey, but also aids in evading larger predators such as tigers. Beneath this patterned coat lies a body optimized for explosive acceleration, enabling the animal to move with remarkable quickness despite dense vegetation. In the forest understory, speed serves a dual purpose: to close the distance to prey during a brief chase and to reposition quickly in ambush. Unlike open-terrain hunters, the clouded leopard rarely engages in long pursuits. Instead, it relies on a combination of stealth, acute sensory perception, and explosive acceleration. When a potential prey animal, a small deer, a wild boar, or a macaque, strays within range, the leopard launches a sudden, rapid burst of speed lasting only a few seconds, sufficient to overcome the victim before it can react. Among all large cats, the clouded leopard stands apart as the most proficient climber. Observations from both the wild and captivity show that it can ascend and descend trees headfirst, a rare ability among felids. Its shoulder and back musculature are exceptionally flexible, allowing it to twist its body while maintaining grip. The animal's hind ankles can rotate up to 180 degrees, enabling it to cling to bark even while moving downward, a behavior more often seen in smaller arboreal mammals such as squirrels or martens. This mastery of vertical movement serves multiple ecological purposes. The clouded leopard often uses trees as vantage points to observe potential prey, to rest away from ground dangers, or to consume its kills in safety. In some regions, individuals have been observed dragging carcasses up into the canopy, much like true leopards in Africa, to protect them from scavengers. Compared with the cheetah, whose peak speeds exceed 25 meters per second in short bursts, leopards are slower but more versatile, able to take heavier prey, climb, and operate under more habitat types. Leopards' strength allows them to drag prey into trees, a capability cheetahs lack. While leopards sacrifice some top-end speed, they gain in stealth, power, and ecological flexibility. Leopards possess a compact but muscular body, with powerful forelimbs and hind limbs that facilitate rapid acceleration and control during sprints. Their vertebral column is flexible, aiding in stride extension and contraction. The tail, which often measures up to half the body length, acts as a dynamic counterbalance during rapid maneuvers and turns. The limb bones are relatively robust, trade-offs being made between strength for dragging prey, including climbing with heavy loads, and maintaining agility. The retractable claws provide grip on variable substrates during acceleration and turning. Leopards must maximize power output during short bursts, while minimizing metabolic costs when stalking or traveling. As with many ambush predators, the balance is in minimizing energy expenditure during search and stalking, and deploying muscular power only during the attack phase. Studies integrating GPS/IMU collars show that leopards spend a substantial portion of active time in low-speed or meandering movement modes, reserving high-speed bursts for the final phase of a chase. Several factors limit the realization of theoretical speed potential in the wild: terrain complexity, rocks, foliage, slopes, obstacles and concealment needs, prey, evasive maneuvers, and unpredictability. The leopard is predominantly solitary, with individuals occupying overlapping territories marked by scent and scratch marks. Adult males and females typically come together only during mating periods, and contact between individuals is rare outside of these times. However, recent field camera data and radio tracking studies have begun to reveal more about their interactions. In areas with abundant prey and secure forest cover, male and female home ranges may overlap for extended periods, suggesting a degree of tolerance rather than strict territorial exclusion. Family ties, though brief, demonstrate a fascinating balance of independence and instinct. Young cubs remain dependent on their mothers for food and protection for several months, during which they learn to climb, stalk, and hunt through observation. Once mature, they disperse to establish their own ranges, carrying forward the genetic and behavioral legacy that has enabled this species to persist for millennia in one of the world's most complex ecosystems.